Good morning students, myself Neeta Kalra. I am senior lecturer of computer engineering from Government Polytechnic College, Ludhiana. So today my subject is system analysis and design, and today we will cover the topic is the introduction and the overview of the system analysis and the design. So today we will cover the contents of this subject, like the introduction of the system, in which we will cover the characteristics of the system, the elements of the system, the types of the system, and then we will cover the common types of system, the overview of the system, in which we will discuss the system analysis and design and the system development life cycle. So first of all, the concept of the system. As we know that the systems are created to solve the problems, and it tends to focus on developing a systematic and the complete structure. That is the concept of the system. I will repeat again, systems, they can be created to solve the problems, or we can focus on developing a systematic and complete structure. So the definitions of the system is like, first of all, we can say that the collection of components that work together to achieve some common goal. Again I am repeating, the collection of components that work together to achieve some common goal, or you can say orderly grouping of interlinked and interdependent components that work together to achieve a specific objective. Or one more definition of the system is a combination of resources that working together to transfer inputs into usable outputs. Again I am repeating that the combination of resources that working together to transfer inputs into usable outputs. So these are the definitions. So there is some examples of the systems. First of all, like the common example of the system is like your computer systems, in which the different parts of the computer system, like your CPU, like your keyboard, like your monitor, all these are the parts of the, and they make the complete computer system. Like your water supply system, like your education system, where the teacher can gives the information to the students and students gain the information. This is complete a education system. Or you can say our target is to do the work, or our target is to achieve the money. So we will do the first of all the primary education, then the secondary education, then further education, and then we will go for the higher education. And the main motive and the main target of this education system is to do the work. Then next example of the system is like your solar system. There the different planets are there. And the best example is like your Edusat system. The Edusat system means where the in the hub in the Mohali, I am delivering the lecture to all the polytechnics of the Punjab. All the students of the polytechnic, they gain the information from this hub. This is the Edusat system of this best example of the system. Like your electricity system. The next is the components of the systems. Components, there are the main three components of the system is like your input, the processing, the output. Input means give the raw data into the processing, and after processing that gives the output. So these are the three components, basic components of the system. Again I am repeating, the basic components of the system is like your input, processing and output. So next is what is the characteristics of the system. There are some characteristics. First is organization, the interaction, the interdependence, the integration, last but not the least the central objective. Again I am repeating, the characteristics of the systems are like your organization, interaction, interdependence, integration, central objective. So first of all, the organizations mean an ordered or arrangement of certain components of a system according to our requirements or our specification. Means the organization, again I am repeating, an ordered or arrangement of certain components of a system according to our requirements or the specifications. If we take the example of organization, say the best example of organization is like your college. This picture as shows like college organizations means the principal, under the principal the different HODs of the different departments like CSE, like ECE, like mechanical, and हर एक डिपार्टमेंट के अंडर द लेक्चर्स देन अंडर द लेक्चर्स द स्टूडेंट्स. So this is the basic organization of your college. This is the best example of your organizations. So next is your interaction. Interaction means the way with which each components work with the other components of the system. Means in the system how the components they can interact with each other and how they work. So again I am repeating, the way with which each components works with the other components of the systems, right. The system that consists of subsystems, sub-components, that is called your subsystems. The different types of components, that is called your subsystem. All these subsystems that make the system. The best example of this interaction is like your computer. Again we are talking about the computer system, like where the different parts of the computer they can interact with each other to achieve the goal. So interaction is the components that works with the other components of the system. So again we are talking about the our college, like the principal can interact with the HODs and HODs can interact with the lecturers and lecturers they can interact with the students, and same the opposite, then same students they can interact with the lecturers, HODs or the principal. So next is your integration. Integrations means it means tied together or attached, or you can say it is sharing a physical part of the system, sharing a, like here again we are talking about your computer system. There are different types of physical systems like your subsystems, like your monitor, keyboard. They can tie together or they can achieve the single target. So this is the integration. These characteristics tell us how the components of the system attached or tied together. So all the components of the system that work together, therefore it has to be clearly defined how they tie together in order to avoid any confusion. So this is integration, means that is clearly defined that how they are tied together in order to avoid any type of confusion. The target is means the common goal, how to achieve and how they integrate, and then how to avoid any confusion. Next is your interdependence. Interdependence means how the components of the system that depends upon each other. Again I am repeating, it means how the components of the system that depends upon each other. All the components are related to each other. The interdependence, they depends or link together according to a particular plan or in order to achieve a specific objective. Or you can say the output of one component is the input of the other component. Again I am repeating, the output of one component is the input of the other component. And the same thing is how to achieve a specific objective, so they can interdependence to each other. Like here this is the best example, the user area where it gives the application to the system analysis, then they do the programming and then perform the operations. So next is the central objective. This is the main characteristics of the system, like without this the system cannot be completed. The system is means the central objective, an objective that can be real or stated. In which central objective means how to achieve your target. कोई भी सिस्टम को क्रिएट करने से पहले फर्स्ट ऑफ ऑल वी हैव इन आवर माइंड दैट व्हाट इज योर टारगेट, what you want to achieve. So what is your objective? So this objective that can be real or that can be stated. So that is very compulsory, that system that must be goal seeking. So, stated objective that may be real objective. The user must know the central objective of a computer application earlier in the analysis for the successful start or end. किसी भी सिस्टम को एक यूजफुल बनाने के लिए, एक स्टार्ट करने के लिए, एक एंड करने के लिए, यू मस्ट बी नो द सेंट्रल ऑब्जेक्टिव. So these central objectives that stated means the stated that may be stated or that may be real, or you can say the stated objective that may be real objective. So next is the elements of the systems. There are different types of the elements that can be used in the system. So these elements are, first of all, the output and inputs, processor, control, feedback, environment, and last but not the least, boundaries and interfaces. Again I am repeating, the elements of the system is like your output and inputs, processor, control, feedback, environment, boundaries and interface. First of all, we will discuss the output and inputs. Outputs means the major objective of the system is produce an output that has value to its user. Means that we can create the objective, or you can say that we can produce an output that have some value to the user. So it is necessary to specify that the nature or the amount and the regularity of input that needed to operate the system. So we can say that a system feeds on input to produce the output by processing on that inputs. Again I am repeating, a system that feeds on input to produce the output by processing on that input. So again I am repeating, the nature of the output that must be in line with the expectations of the user. So that should be clear, that the nature of the output that it must be in line with the expectations of the user. The inputs, that are the elements that enter the system for processing. What are you giving the input to the system and how to process, and how to, that gives the useful information to the user. So next is the processor. Processor is, this is the element of a system that involves the actual transformation of the input into output. Again I am repeating, the processor is the actual transformation of input into output. So next is the control. Control, that control is that element that guides the system. It is the decision making subsystem that controls. If we are talking about here, this is the best example of your college, is that principal that controlling overall the college, management, head of the department that controlling overall the on departments. So the control means that guides the system. It is the decision making subsystem that controls. The next is your feedback. Feedback that measures output against a standard in some form of procedures that includes communication and control. That may be dynamic. So the feedback that measures output against a standard in some form of procedures that includes communication and control. So the feedback that may be positive or that may be negative. If this is the positive, then they this is good, that they the workers of the suppose if we are taking about example of the any company, if there is positive feedback of any person, that is good for the, that creates a very good environment to the company. So the feedback that may be positive or that may be a negative. The next is your environment. The environment, it is a super system within which an organization operates. The environment, it is a super system within which an organization operates. It consists of vendors, competitors, which influence the actual performance of the business. Again I am repeating, the environment is a super system within which an organization operates, or you can say it may be consist of vendors, competitors which influence the actual performance of the business. So, this is the example of this, that the group of people they are trying to compete. So, these are the vendors and these are the competitors. So, next is your boundaries and interface of the system. A system that should be defined by its boundaries that identify its components, processors and interrelationship when it interfaces with another system. Boundaries and interface that should be defined by its boundary, that should be defined, identified by its components, its processor and the interrelationship when it interfaces with another system. So, next is the types of the systems. Types of the system is, first of all we will discuss the physical system, the abstract system, natural system, man-made system, open system and last but not the least is your closed system. Again I am repeating, the types of the system is like your physical system, abstract system, natural system, man-made system, open system, closed system. So, first of all the physical system, as we know this thing, physical system is like your computer system, the environment, like your classroom, like your desks, like your chairs, all these are the physical systems. So, the physical system they are tangible entities that may be static or that may be dynamic in operation. So, a programmed computer is a dynamic system. So, physical system they are the parts, like your the best example is physical parts of the computer center are the examples are office, desks or chairs are static. So, dynamic system is like your dynamic is your programming in the computer, that means the physical system that may be tangible entities, that may be static, that may be dynamic in operation. Dynamic means like your computer programmed, or the static means like your the physical parts of the of your computer center, like your office, like your desks, like chairs, all these are static physical system. So, next is the abstract systems. Abstract systems are conceptual or non-physical entities. It may be as formulas of relationship among sets of variables or models. If we are talking about the quadratic equation like ax square plus bx plus c is equal to 0. So, this is the formula that gives the relationship that where you can find out the values of x1 and x2 and then you can find out all these relationship. So, the abstract system means that these are conceptual or non-physical entities that may be as formulas of relationship among any sets of variables or the models. So, next is the natural system. As name shows, natural systems are the system that is created by the nature. There are so many examples like your solar system, like your geological system, molecular system, brain system. These are the best example of your natural system. So, again I am repeating, the natural systems, these are the systems that can be created by the nature, like your solar system, molecular system, brain systems, etc. So, next is the man-made systems. Man-made systems, they are created by human beings to serve a particular purpose in a particular environment. Like again I am repeating, the man-made system mean man-made system, they are created by the human beings to serve a particular purpose in a particular environment. Like these are the example like your social system, like your transportation system, like your communication systems. So, the man-made systems that can be created by the human beings to serve a particular purpose in a particular environment. So, there are some examples. First is the open system. Open systems are those systems which interact with the environment. Open systems are those systems which interact with the environment. The examples are the collection of interacting software, hardware and human components. Open systems means these systems which interact with the environment. The example is like here the collection of interacting software, hardware and human components. So, the closed systems are those systems which do not have interaction with environment. Open system means they interact with the environment, and the closed system they do not have interaction with the environment, or you can say the no information is exchanged within its environment. So, closed systems that do not have interaction with environment, or you can say the no information is exchanged within its environment, or you can say they are not self adjusting and regulating. So, these types of closed systems they are rare to be found in the reality. Okay, they cannot receive input because it has some restrictions and boundaries. So, there are some more common types of systems are like automated system, management information system, decision support systems. Some more common types of systems is like automated system, management information system, decision support system. Automated systems, these are the systems that man-made systems that interact with or are controlled by one or more computers. Automated system that is based on the computers that is the man-made systems that interact with or are controlled by one or more computers. These types of systems that is called the automated system. So, there is some categories of like your batch systems, like your online systems, like your real time system, decision support systems and knowledge base system. So, next is the management information system. Management information system is a person machine system and a highly integrated grouping of information processing functions that can be designed to provide management with a comprehensive picture of a specific operation. Again, I am repeating, the management information system, that is a person machine system and a highly integrated grouping of information processing functions that can be designed to provide management with a comprehensive picture of a specific operation. So, next is the decision support system. Decision support system is an approach that uses an information system to assist management in formulating policies and projecting the likely consequences of decision. Again, I am repeating, decision support system is an approach that uses an information system to assist management in formulating policies and projecting the likely consequences of decision. The next our topic is the overview of the system analysis and design. So, system analysis and design, we will use the system development life cycle. So, system development life cycle that revolves around a life cycle that begins with the recognition of user need. So, why we are using the system development life cycle? So, that revolves around a life cycle that begins with the recognition of user needs, or you can say the system development life cycle is the basis for learning system analysis. Again I am repeating, the system development life cycle is the basis for learning system analysis. There are some phases of system development life cycle. First is the preliminary study. Next phase of the system development life cycle is the feasibility study. Next is the detailed system study, the system analysis and design, then the implementation and the maintenance. So, these are the phases of the system development life cycle. First of all, the preliminary study of the system, that is, you can say the recognition of the system, the recognition of the need of the user. The next is the feasibility studies, that may be technical, that may be operational, that may be economical. So, detailed study, that is after the preliminary study, there is a, or you can say this is the detailed study of the all the subsystems of the systems. The next is the system analysis and design, where you can perform the system can be analyzed and then they can be designed. Then the implementation, that is the actual implementation, actually the system can be performed. The next is the maintenance. So, first of all, the preliminary study. Preliminary study is the brief investigation of the system under consideration and gives a very clear picture of what actually the physical system is. So, again I am repeating, preliminary study, preliminary system study is a brief investigation of the system that under consideration and gives a very clear picture of what actually the physical system is. You can also say that the preliminary study can also be called as the system study. So, system, this is the very first part of the system development life cycle, that means you can say this gives a very clear picture of what the actual physical system. And in practice, the system study is done in two phases. The first phase is the preliminary study, or you can say the preliminary survey of the system is done, which helps in identifying the scope of the system. Again I am repeating, means the first phase, that is the preliminary survey of the system is done, which helps in identifying the scope of the system, and the second phase is the system study is more detailed, or you can say in the depth study, in which the identifications, or you can say the user requirements and the limitations and the problems of the present systems can be studied. So, preliminary study, that is the very first part of the system development life cycle, very first phase of this system development life cycle, that gives the very brief investigation of the system and that gives the very clear picture of the system. So, this is an example like the nature means what is the problem and where is the opportunity, and the scope means exactly what is the area under study, and the objective what is your target, means what should the system be able to do. Is it clear? So, nature means that is the problem, what is the problem and where is the opportunity, how to solve the problem. Then the scope exactly what is the area under study, and the objective what should the system be able to do. So, next is the feasibility study, that is very important phase of this system development life cycle. So, the feasibility study is the test of the proposed system in the lights of its workability, meeting users' requirements, effective use of resources, and of course, the cost effective. Again I am repeating, the feasibility study is the test of the proposed system in the light of its workability, users' requirements, effective use of resources and the cost effectives. So, basically the process feasibility study that can be based on three aspects. One is technical feasibility. Technical feasibility means during this study, the analyst identifies the existing computer system that may be related to your hardware, that may be related to your software, and determines whether these technical resources are sufficient or not. Second, as